स्ट्रीम चालू केलाय. स्ट्रीम दिसत नाहीये.
स्क्रीन आपण दिसतोय ना?
Let us start with Leetcode first.
Okay, so the question is, given a root of a binary tree, each node in the tree has a distinct value. Okay, so the question is, will be a binary tree, and we have to delete certain nodes. And after deleting the nodes, whichever the trees that gets created, we have to return the root nodes of each tree. So yeah, one thing we can do is, So let's say this is our tree. Okay, are you able to see the screen? So let's say this is our tree, and first of all, we want to delete three. We want to delete three. So what we can do is, first of all, from the root, go to the three. We arrive at three. First of all, our root node will always be in the solution. After that, when we cut out the particular node, the left and the right of that particular node will be added to the solution. That this is the whole solution. This is the whole funda behind that. So first of all, we have to look for DFS. We have to go depth first, because if we go breadth first, then let's say if we go breadth first, then there might be a certain challenge that if, let's say, if we also want to delete 6, but the 6 comes after 3, let's say there is 3 comma 6, then we will first see 2, then 3, then 4, then 5, then 6. Okay, so 6 should not be in the solution, but the if we go breadth first, then 6 added gets added to the solution. So that's the whole funda behind why we are going to use depth first. So this is the intuition behind it. Do you have any solution behind this other than this? You can turn on your mic. Yeah, I'm not able to hear it. I think the solution is pretty easy. It is pretty easy to code also. Let's give it a try
So
first.
we have given BFS, right? In input, we have given BFS.
No, it is not search tree. It is only binary tree. It is not a search tree.
We have given BFS in our input as a input. BFS of tree is given as input, right? No, first example we
Okay,
have
okay.
seen so BFS
Yes,
of that
yes.
tree is given as
Yes,
input.
yes, 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 yes. BFS of a tree.
Binary,
Right, 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 right.
strictly binary.
Yeah, yeah. They have mentioned it that this is a binary tree. It is not a binary search tree. This
It's not
so we can go depth first. We can go depth
we
first,
that
and after that we will see if the particular, let's see, uh, for this 3 and 6, for 3 and 6 how we will do it. 3 comma 6, first of all we will go to the root node. We will add the root node to the solution. This is, let's say, this is our solution vector. We will add 1. After that we will go to the 2. We will go towards 2. We will see if 3 or 6 is in the uh, if the particular value of current node matches with the any value in the array. If it's
yes.
that case, then we will add the root nodes of the particular in the solution. But before that we have to check if the root nodes are in the solution, in the given to delete vector. If that's the case, then we have to move forward further in the tree, right? We have to move further in the tree.
Our plan is to check if the root node is in the array.
Yeah, yeah,
If it's present in array, its left and right subtree
will be added
will
in
be
the
direct
solution. Yeah,
solution. That node is popped out from that array.
yes, yes.
Okay, because it's not uh, binary search tree, and is there is given that there is no repetition.
Yes, yes. nodes, every value will be unique and distinct.
Okay. So after removing that, we can search for next one.
Hmm, hmm. Yes, yes.
Okay.
One more thing, let's just extend this question. Let's say here is 8, and here is 9, and here is 10. First of all, we are told to delete 4, and after that we are told to delete 9. Or let's say we are told to delete 8 also, 4 and 8.
Ah,
So first of all,
yes.
we will go to 2, we will check if 2 is present in the given array. If it's not, then go next. 4, we will check for yes, 4 is present. Then we will try to add both of the left and right to the particular solution. But we will check if the particular given left or right is present in the equation to delete. If it's not in that particular array, then we will add 8. But since in this case the 8 is present in our input argument vector, we will try to add left and right of this it. So we will have a recursive call. So first of all, we will delete the node that is close to leaf. After that, we will move to the root. We will
Okay.
go
Um,
bottom up.
and then while backtracking, we will check it's present in the array.
Yes, yes, yes.
And we will, if it's present, we add the leak nodes.
Yeah. But
Yes.
one thing is that the time complexity becomes too much. We have to go through entire array for each and every node. So let's say there are m nodes, and there are n is the size of array. M into n will be the time complexity.
Okay.
So we can do it in m time. We have to see how we will do it. If we use unordered map, I think we are able to do that. We can convert this particular array into unordered map firstly, and after that we will check
Okay.
for every unordered map hash map. We can use hash map, convert the input array into hash map, and then we can perform it O of 1. So we will require extra n time complexity, space complexity, and our time complexity will be only m number of nodes.
Okay.
So this is my proposed solution.
The approach is clear. We got the approach.
So for this, how we will be able to do it? So first of all, we have we have 1, after that 2, and then 4, then here is null, and here is 3. For this we want to delete 3. I think they wanted to delete 3. Yeah, they wanted to delete 3. So first of all, what we can do is for 3, we have to delete 3. We can go, we will check if the particular current node is present in the hash map. If it is not, then move towards the left. Then we will check 2. 2 is not present in the hash map. Then we will check 3. 3 is not 3 is present in the hash map, but the root nodes are null. So no need to add null, right? There is no need to add null nodes because this is a leaf node. If this is a leaf node, then it is ready to go. There will be no any particular or no additional binary tree forming in our forest. So for this tree, there will be only root node added to the our particular solution. One more thing, they have told to return a particular entire tree. We don't need to add only root node. We have to perform the, I think they have performed, yes, they have performed BFS.
Hmm.
Yeah, we have to
Oh,
perform BFS. For we can keep track of vector. We will insert all the root nodes, and after keeping track
we
of,
add when we add the root node, uh, it will automatically check, or we need to add. Uh, if you have seen the return type, it's a vector of tree.
yes, yes, yes. That's what I'm telling you. First of all, we will have a vector of nodes only. After that, we have a vector of nodes, and after that, in solution, we have to parse. We have to take this. We have to treat each node as a root tree, root of the tree, and we have to perform BFS on that, and we will add a particular each visited node to our solution. Have to push back each and every node that we are accessing. So we will have two functions. First one will be to keep track of nodes that are getting deleted and adding the root nodes that are forming. And second will be calculating each tree. So how can we do it?
Need to create array separate and then again convert it to tree. Means, as we have discussed first only, we will go to the left, 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 and when we return back and
Hmm.
we check the right, left, 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 uh, and if node is present, means if we found that it's present in that deleting values, then if it's left, nodes left, we will push into the tree, means what's the forest, into the forest only, that below node. And if it's right, that push into right, means right side, node of right side, and delete that node directly. And return its, means when we deleting the node, we should convert into null pointer. Means, when we, if the example is 2, okay, if you consider 2 as a deleting node,
Hmm.
um, went, first we went to first that processing, second left side became, when we processing, um, at the time of processing we will check if the value is present in that vector. If the value is present at vector, if it's left side, if it's node of left is present. At 2, 4 is present and 5 is present. So push
Yeah.
that directly the forest and delete 2 itself and return back. Means we don't need to go to whole depth and go back.
Okay, I got you, but what if that's what I discussed? If we want to delete 2 and we also want to delete 8, you know what I'm getting.
Yes, yes, yes. That one, that one.
If you want to delete 2 and I also want to delete 8, then we are not going to 8. So how can we delete it?
Mm.
We are not deleting it. If we are not accessing it, then how will we will be able to identify 9 and 10, right?
Then, after coming depth at left, we'll go at right. Means after coming at 9, see, after coming at 9,
Hmm.
we don't have any left
Yeah.
because it's null.
Yeah, yeah.
We will go right if right is present.
Yeah, yeah, we will go to 10. Yeah.
We again go to back because
Yeah, we will go to 8.
8.
Yeah, definitely.
8's right. 8's right, 10.
Yeah, 10.
We go to a okay. When we go to 8, we want to delete 8, right? When we
Yeah.
went to 9, we checked 9's left and 9's right.
Yes,
We
yes.
went to, we went up. We found 8's value is present in deleting node. 8's value is present in deleting vector.
Yes,
We
yes.
want to delete. So at that point, we will directly check if 8 has left node as well as right node. If 8 has left node, we will add it into the forest.
Yeah.
If it has right, we will add into the right node forest and delete 8 itself
Hmm.
and return back to 4.
Okay,
So
okay, that's a great idea. So we don't
we
have to
don't need
check for each. Yeah, yeah. We don't
uh,
have to check for each
any
node.
a hash map, creating its vector, again creating its tree again. Better to go DFS we are doing already. So while returning back, if we check.
Yeah, that's a good, great idea. Okay, so how we will code it?
First, DFS means left then right.
Yeah, they read this. The return array must be mallocated. Assume caller function calls free.
Note is there. You're opening C, right? C language.
Oh shit. Yeah, yeah, yeah. Now it's good to go.
C plus plus.
Okay, so tell.
First, create answer node. Answer means we are returning return type vector tree node answer. Okay. Mm, Left traversal, then right traversal. Create separate function better because it will create tree node again. Um,
I
Left
have
travels.
one optimization solution. I think we should use a hash map uh, to check because if we are giving vector as a argument, then we have to traverse whole vector. You know,
Okay.
are you getting
Uh,
what I'm telling you?
you should use. a data structure where we can have dot point function.
Yeah, yeah. Lookup should be fast.
Uh, which will be better
Hash
for
map,
dot find?
unordered map.
Okay, then create an order map, pass the vector, begin to vectoring. Right.
Unordered map will have tree node, right?
We know
Then what will it have?
we are passing the integer only, na? Vector integer.
Yeah, yeah, yeah. So this will be our map, and for int a in so first of all, if uh, current node is null, current node is null, then we will return a
Am I audible?
yeah, yeah.
Yeah. Uh, First, we will
I
write what we
think
know.
I think we should firstly solve it in the Python. After that, we will see in, because we haven't solved any tree problems. So let's try to solve. So we have self root. So root is list of tree node and to delete is list of integer. So we have to return a list of tree nodes. First of all, set to delete is equal to, we will have to convert first of all into set, right? After that we will have dfs, we will have, which will have root, and if we will have none, then we will return none if node is present and node is in, if node in, then what we will do, Hemant, if, what wait a minute.
Okay, sorry. First, we should go to the direct left, right, and direct right. DFS, all recursive function for left and then right. DFS node left and node right.
Okay, so first of all we should have solution, then solution
One
is, is
solution.
set, and set should be initialized to root, right? After that, if node is present in the,
First, we are going DFS
yeah,
left.
yeah, but if we
First,
have to delete a particular node, so let's say we are going to the,
okay.
yeah, so we
When
have
we
to delete
find
it
the
from the
node,
solution, we have to delete it,
when we find the node,
yeah, yeah, we have to delete it from solution.
when node's value, when the node's value is present in that list. Node dot value, right?
Yeah, yeah.
Hello.
Ah,
Node dot value. That if condition know that node dot value.
yeah.
node dot value
Hmm.
is present, we will add its left and right node into our returning list forest.
Solution dot append na append.
Yes.
But first of all, we have to go left. So we will have left is equal to dfs of node dot left. After that, we will go to the right is equal to dfs of right. Hey, we have to check for null also. We have to check for null.
Okay.
So if left is present, then we will add solution dot append left. Same goes for the right.
Left node, directly left node.
Yeah.
So we add its parent, child nodes. All nodes are added. We need to delete that parent node.
Yeah, we have deleted this. Look.
Return back, right?
Then what we will return? Yeah, what should be returned? What variable we are? We want to return list of tree node. Mm, Then we will return list. Okay, so we are not breaking anything. Shit.
Just little bit code. What if we put out that left and right traversal before if?
Yeah, I also thought of that. Hmm, hmm. I think I got it. We have to do node dot left is equal to left and node dot right is equal to right. Yeah, what the hell? Wait. We are in the if, and do this, do this. Yeah, we have to be outside the if condition. No, it's still not working. I'm done by 7. It's not node, then if root deleted is equal to if root deleted is equal to node dot val in set to relate. If is root, but oh fuck. Shit. We we didn't call DFS.
What happened?
We didn't call DFS. Function we have written function but we haven't called it.
Okay.
So we have to first code DFS root. Yeah, Hey,
Hmm.
let's see this. I think this is, yeah, two pointer. Let's try to solve a two pointer container
Yes,
with.
yes.
Now we
I
can
have
go with.
seen this.
Okay,
What else?
we are given an integer array height. We have O of one solution. Often, often. How can we do it in often now?
What if we found the leftmost greatest and the rightmost greatest?
I don't think so that will work. We have to calculate area between 2 points.
Leftmost greatest
Okay,
and rightmost greatest.
okay.
So, not the greatest.
And
Um,
that motivation. Okay, so here we will have this 8 and this 7. Okay, if if you go with your approach, we will have this and this. But what you want to calculate? What will be the maximum area that will be covered by the water that we want to calculate? So we will have. I have a brute force solution in which we can calculate the area between each of two distinct poles, right? So we'll calculate area of each. We will have a priority queue, and in that priority queue, we will have a pair and the whatever area that is present between that two poles, and whichever will have most of the area, that pair will be our solution. You know what I'm getting? Are you getting what I'm trying to telling you?
your connection is my connection is on.
Hello, am I audible now? Hello, hello. Yeah, that's we have answered. That's point to the lower line. Yeah, if you simulate the problem in square, brute force approach will be in square. But they are telling that we can solve it in the of n time. Suppose we have problem like this. Okay, here are some containers. What if these two are maximum? Let's say this the area between these two is maximum. Let's say this is 100 and this is 100. Okay, so automatically our solution will be between these two. Cause if we go between these two containers, it will be it will not be that much that we are getting here. We will get, let's say instead of let's say we have 10,000 and here also 10,000, then the difference between the x distance will be 1 and y distance will be 1,000. So sorry, 10,000. So our area will be 1,000. So this must be our solution optimally, I am telling. So even if we go between any of these two, it it will not be that much of that we are getting here. So how we can approach, like, we have to parse both of.
Okay. Now, I think if we put two pointers,
Hmm?
one is left,
Yeah, yeah,
start with 0, 0. Okay,
yeah, yeah.
start with 0, 0, and right will first right. Uh, okay, okay, we need to find that sum around sum and the next sum. Uh, uh,
Yeah, we can have max area as a max area.
okay,
We can have max area variable, which will have the maximum calculation between lowest of these 2 points, L and R, lowest of these 2 points, into the R minus L, into the distance between them. L R minus L minus 1, minimum between L and R and distance between L and R. That will be our area, right? Uh, Leetcode is telling try to use two pointers, set one pointer to the left and one to the right of the array that we have done, but always move the pointer that points to the lower line. So we
okay.
have,
We have left pointer and right pointer.
yeah,
We find the minimum, which is minimum, smallest. Okay.
hmm,
First, we will find how much water capacity they hold.
hmm,
Okay.
hmm, hmm,
First, we will find how much water capacity they hold and multiplying the minimum value into the size between them.
hmm, hmm.
Okay. And we will increment or decrement the left or right pointer. So who has minimum? Yes.
Okay.
Can you just show that diagram before one in that website? Okay. We will start with 0 and n. Okay. 0 is left and right. We got. Okay. And our first left and right we got.
So first we will have
Our
L
first
and here will be R. Okay. After that,
okay, one, two, one, two, three. So first our water capacity will be 7 because lesser left
wait,
pointer
wait,
is
wait,
1
wait, wait,
only.
wait, wait. We have to return. Okay, so we have to
Yeah,
return maximum
how
area.
much? How
Okay, so
much?
we have to return maximum area. We don't have to return which.
Okay.
Yeah, yeah.
So what we will do? We have first calculated. Okay,
We don't have to
you are not
calculate.
audible.
Hello, am I
Ah,
audible?
yes.
We don't have to return which two poles are having maximum capacity. We have to return maximum capacity only. We don't have to keep
Yes,
track.
yes.
Yeah.
And we will compare only. First we um, left and right we have. Also say take the area. Right now they are covering. Okay.
So, hmm,
And whichever is the lesser one,
hmm.
will increment or decrement that. In this
Okay.
case,
We
will
have to
left
increment L.
plus plus. Okay.
Yeah.
And the new upgraded area will be compared with the older one.
Yeah. Okay, okay. I'm getting. I'm
The
getting.
older one. The maximum will be stored.
Hmm.
Okay. Right now we got the 49, right?
Hmm.
Here
Yeah, we have.
in between L and R, right one is smaller than R.
Yeah.
Hey, right one is smaller than left one. We'll go back. When we calculate this area will be still less than the previous one. The same will be written. Again, right minus minus will be there.
So what if both are equal? We can go either.
Uh, uh, uh,
Okay, so let's say
but
we
if you calculated this, the area between one
these two will be
area between is how much will be there? 7, 7, 7. In between there are three poles, right?
7
Three
into 5,
poles. So
35.
7 into 3, 35. Before it was how much? At first, that is green, both green candles. 6
6
into
so 6 into 1, 2, 3, 40. स्क्रीन अटकली तुझी.
this.
6 into 7 will be our, yeah, 6 into 7. Okay, why are we getting, okay, so this is 7. Okay, yeah. Yeah, 36, right. As I
Got
said,
it?
L R minus L minus 1. R minus L. R will be 0, here will be 1, here will be 2, 3, 4, 5, 6, and 7.
आपण एकच लूप टाकणार while
Yeah,
loop until
while L is
left
greater than R.
overlaps.
Yeah. So let's code it up.
And first we will get current capacity and compare with max capacity. Just initialize max capacity as int min.
Yeah, so I think we should be able to code it up, right? I didn't pay attention to the output. I thought we have to return the two poles that are getting the
Pointers.
maximum. Yeah, yeah,
Hmm.
yeah. So I was not
So
able to get the
complexity.
solution which was of n. So I
If
left.
to be in that case also we could retain the position
You are
is
not audible.
max.
Your voice is not audible. I mean, I can hear you, but volume is.
It's
Yeah, yeah, yeah. No, I can hear you.
system. In that case also, what will happen if current pointers are is current is when we first calculate now, if current uh, what current area is max,
Hmm.
we store the uh, pointers. And if it's, right now how we are storing max area ना जैसे max area store करू क्या तर आपण max pointer store करायचा त्यावेळेला आणि पॉइंटर अपडेट करत जायचा पॉइंटर आणि मॅक्स पॉइंटर नवीन असं लोकला क्वेश्चन पाठवता येते का
Hmm.
आपल्याला लीड कोडला क्वेश्चन पाठवता येते
ईमेल करता येतं.
करून टाकूया असणार नाही ठीक आहे मॅक्स एरिया लिंक देईन compare the height of left with height of right compare height of left with height of course
Hmm.
calculating the current area function current area calculation
Yeah, cause here itself we have decremented right by one.
Actually, that in between area is there none. We have shown pillars, put pillars in between. It's not present there. I saw Apna college video. They told that pillars are closely attached to each other. But in visualization, they have shown that there is a gap between pillars. They're closely attached.
Yeah, yeah.
There is no gap. Left hand side. I submitted it.
We have got to Afan, but solution is not optimal.
Okay. Almost. Oh, and login. What is the
Yeah,
solution? Same only.
yeah. 68 lead code. Particular lead code.
Title
आधी आधी 70 येत होते आता 58 आली रे. ते
is
व्हॅरी व्हॅरी
compiler काय तर असते ना ते.
व्हॅरी
Cloud,
करते.
cloud.
Okay, so we will continue the stream
It's,
after.
it's a break time.
I think we should continue at 11, 10:30, 11.
11, 11 and 13.
Yeah, we will continue at 10:30 then. Yeah, I will pause the stream for now.
1 hour.
Yeah,
Oh, fine.
do you know how to pause stream?
We need to be end on this.
Hmm? Nah, nah.
Yes.
I think we can pause, but I think we have to go there.
Oh, yes, nice. You could stop.
See, see,
We
see
will continue running now.
yeah. See the screen.
It's still running. YouTube still YouTube running.
I think we should look it up.
Okay, it's not showing blank.
Yeah, yeah.
Do one thing, hide all the screens. Yes, that scene was there, right? Scene. Hide that scene also. One thing, OBS,
Might be wondering, well,
that
why do
first
I want, and they want to go live
scene was
function
there
to
now.
use up now. And now my camera
You
one is
hide
paused.
that
Everything else,
scene
again, it's going,
when I told
so I
you
can pause.
go black
Click to
screen
watch.
only.
What's up, guys and gals? I'm your host, Mike Pugh of the FPC Virtual. I haven't done in detail. Sometimes you cannot tell when.
ते हे कर की सीन मगाशी आपण नवीन ऍड केल्यानंतर ब्लँक स्क्रीन आलतीच की
नाही मी आताही केलंय पण मला
ओबीएस
ओबीएसच ओपन आहे थांबती.
सीन मध्ये बंद कर सीन मध्ये सीन ऍड कर नवीन इकडं लेफ्ट साइड सीन ऍड कर नाही पहिल्या कॉलम मध्ये सीन्स मध्ये
आता ब्लँक झालं का बघ बरं.
Grow your career with.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve delete nodes and return forest. A pretty good problem, I think, actually. So we're given a binary tree that looks like this. Every value is going to be unique. It's not necessarily a binary search tree. There's not necessarily any sorted property. But within this tree, we're also given a second parameter, which is a list of values. Those are the values we want to delete from this tree, meaning we actually want to physically delete these nodes, meaning delete this node and delete this node. Now, after we delete all the nodes, we are going to end up with this. Like imagine this is gone and imagine this is gone. Now we actually have 3 trees. We have one tree over here. Since this node broke, this is not, these children aren't connected either. So this is by itself. We have 1, 2 remaining. What we want to do is return the root of each of these trees in the form of a list. So there's 2 phases of this problem. Do the deletions, obviously, and second is collect the new roots. Believe it or not, phase 1 is so much easier than phase 2, so I'm actually going to start with it. How do I know it's easy? Because usually when we're doing deletions in a tree, it's actually pretty hard. It's kind of complicated. Just thinking about it might make you nervous, but let me tell you why it shouldn't. Usually when we delete a node, we need to replace that node and then, do a bunch of pointer manipulation to make sure that this stays connected. But we actually don't need to do that in this case. So actually the deletion is going to be trivial. I have a pretty deep understanding of trees. Most of this stuff I think I cover in my beginner's course actually, so you don't need to be like a super expert. Doing a deletion on a binary tree isn't super hard. There are 2 ways to think about it. Think about it from the root perspective, like the parent perspective rather. Suppose we're trying to delete the node 2. We could do it from the parent, right? We could say, okay, my left child is the node that I'm trying to delete. So how do I do it? Well, we don't have to set the pointer to all the way down here. We can literally just set the pointer now to null. That is one valid way of doing it. And then, maybe we could run DFS here to delete some of the other nodes. Delete 4 maybe, delete 5, whatever. That's a valid way to do it. I prefer to kind of do it bottom up. So I'm actually going to code it up where I'm going to keep that connection so far. I'm going to recursively then run DFS here. We can actually do all of these deletions in linear time by just traversing over the list once. We go through, of course, like with a recursive DFS, we go through every node, starting with the left subtree, then going to the right subtree. Every time we see a node that we're trying to delete, this is what we're going to do. We're going to return up to the parent null. So if this is a node I want to delete, I'm going to continue running DFS. Firstly, this is not the first thing we're going to do. First, we're going to keep running DFS on all the children. After the fact, after that's done, to my parent, if 2 is a node I want to delete, to the parent, I'm going to return null because from the parent's recursive call, it's going to be simple. We're just going to say, okay, run DFS on the left child. But we're going to say root.left is going to be assigned to the result of that recursive call. I'm sorry that this is written diagonally. I'm not sure what I'm doing. But I hope you get the point. If we return null, obviously the left pointer will then be set to null. But what about the other case? What about from here, 3? What if 3 is not a node we want to delete? Well, it's pretty simple. Just return the node itself, right? Just return this node. Therefore, the right pointer will still be connected. It will remain unchanged. So I hope you understand why doing all the deletions throughout this entire tree is not difficult. So now that we got that out of the way, the harder part might be actually collecting the roots. We're going to need to get a little bit creative for this part. So the first question you might ask is, can we do this as we do the deletions? Because if we can, that would be the best solution. That'd be the easiest way. Or maybe we need a separate DFS to do it. Well, I definitely would rather not do a separate DFS. Can you tell me why? If we break the pointers, gonna be kind of hard to traverse a graph that's not connected, right? I mean, maybe there is a solution where we can do that. It probably wouldn't be a traditional DFS. Maybe while we do the deletions, we should collect the nodes and stuff like that. I don't know if there is a solution with that. Maybe you can think of one, but I can think of a slightly easier solution. Think of this for a second. When we're actually performing the deletions, recall that the nodes that we want to delete, suppose like it's 2 and 6, they're given to us in the form of a list. So the first thing you'd probably want to do is convert these into a hash set. So then every time we see a node, we can immediately look it up efficiently to see if that's the type of node that we want to delete. Okay, so then what do we do? Like, suppose I'm trying to collect the
Hello.
roots. How do you do it? Well, there's no magic way. It's not just going to magically pop up into your mind.
So
So
what
don't
should
be
we do
lazy.
now?
Get
1 minute. 1 minute. Hello.
हम्म.
काय करायचं? अच्छा.
आधी हो व्हिडिओ जर बघा.
कुठला?
नीटकोडचा व्हिडिओ लावला रे.
हा. चालेल. अरे मी ह्याच्यात काय लिनक्समध्ये अँड्रॉइड स्टुडिओ घेतलं आणि शिवाय त्या फाईल्स डाउनलोड काम येते. मी त्या ह्याच्यावर UI मध्ये काही दिसत नाही काय, नुसतं स्टार्टिंग डाउनलोड म्हणून येते आणि टास्क मॅनेजर ओपन केल्यावर मग कळालं की डाउनलोड करायला बॅकएंड टाकायचं आणि समोर काही येत नाही म्हणून मी 3दा बंद केलं. तिथं काही दिसत ना बहुत काय होते 400-500 MB तर मला डाउनलोड केली ऑलरेडी.
बघा.
आवडतं मग
a piece
त्याच्यातून
of
घ्यावं
paper,
लागतं.
draw out some examples and see what you can come up with. This is what I can come up with. We start, initially, we know that we only have one root. So if we don't delete this node, then this is going to be a part of the result. We definitely want to have that node 1 in the result. But if we delete it, we probably want to remove it from the result.
हम्म.
आत्ताच्या लाईव्हची लिंक टाक. लाईव्ह
हाय लाईव्हच आहे की आता रे.
डिस्कॉर्डवर आहे. युट्यूब गेले माझ्याकडनं. सांगता हिस्ट्रीमध्ये ठीक आहे. ब्लॅकच आहे. ते 3 झालो. तो 3 तयार केला. 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 ब्लॅकच आहे. तो 3 हा आत्ता निघालो. काय करतो? काय करतो? काय करतो? काय करतो?
So maybe I'm keeping track of the output, which we want to return in the form of a list. But as we go, removing from this list, it could grow. So removing from it could be inefficient. We don't know. So it might be better to keep track of the result in the form of a hash set to begin with. And then at the end, we can easily convert that hash set into a list in linear time. So that's kind of the intuition of why I'm doing that, but still, let's think of some examples. Suppose I delete the root. Okay, I said we're going to remove it from that hash set. Great. But now what? What is the result going to be now? What are the remaining roots? Well, if we delete a node, if it has a left child, that just became a valid root. If it has a right child, that just became a valid root. And that's not only true when we do so from the root node. Imagine if the root stayed the same. Imagine if I deleted this node too instead. Well, its left child became a root, its right child became a root. So of course we'd add those to that hash set that I was talking about. And we can again do them pretty efficiently. Adding to a hash set is constant time. So we're getting closer. The only thing I want to clarify now is the order kind of matters. Suppose we're doing a DFS, we get to the root, suppose we do want to delete the root. Okay, great. So I'll keep track of like the result. Imagine this is a hash set, sorry. Imagine 1 is initially in the hash set. We deleted it, so we remove 1. But then we'll add its left and right child. Okay, I'm going to add 2, I'm going to add 3. These are the nodes. We're actually adding the nodes, not just the values, because we want to return the nodes. Now we do that. We continue the DFS, we go to the left pointer. Suppose we want to delete this node as well. So that's fine. We can now delete this from the hash set as well. So it looks like the order, just by doing it from top to bottom, is fine. You probably recall me saying that we're actually going to do it bottom up, but the bottom up deletions, that was when we were actually removing the nodes from the tree. By removing, I mean like manipulating the pointers. That's the part that we're doing bottom up. But in terms of collecting the roots, that's what we're actually doing top down. So that might be kind of confusing. There might be a way you can collect the roots bottom up as well, but I think it's probably more intuitive to do it this way, because in terms of collecting the roots, all we're doing is removing and adding from the hash set. I think that's pretty simple. We're not manipulating any pointers by doing this portion, so I don't think it's crazy. Other thing is, one last edge case, imagine we did not delete the root. This is what our result looks like so far. We just have the root in the hash set. Then, suppose we want to remove 2. We want to delete this node. We'll do the pointer manipulation, right? We'll end up returning null to the parent. But if we try to remove this from the hash set, well, it doesn't even exist in the hash set to begin with. So that's an edge case. Before you try to delete from the hash set, make sure it actually exists. In Python, there's a built-in method called discard that will allow us to do that. So let's get into it. I think it's clear that this is going to be a linear time algorithm because we're just traversing over the binary tree. Memory complexity is going to be big O of n, mainly because of that hash set. So now let's code this up. I want to take just 10 seconds to quickly say I finally launched the Python for Coding Interviews course. It has a bunch of interactive lessons like this. We were just talking about discarding from a hash set, and the reason I'm using discard rather than remove is because discard will never give you a key error if that key doesn't exist, whereas this one will. It's something that you could also just use an if statement for, but I think using discard just makes it a little bit more concise. It's kind of worth knowing, I think. In case you were wondering like what my thought process was when I came up with my solution. This is more or less what it was, but let's go ahead and start from scratch. Like I said, this is kind of going to be like a hash set problem. So first, let's convert to delete into a hash set. It's given to us in the form of a list, but we can very easily work around that. And the other thing is the result. I'm going to call it the result set. And I'm going to initialize it just with the root. To initialize it with a value, you have to actually pass in a list. Another thing I think I cover in the Python coding and review course. We're passing in a list with just the root, and this is what we're ultimately going to return. But we want to return it in the form of a list, not a hash set. So let's do the conversion right before we do that. Now for the DFS, I'm going to create a helper function. It's a recursive function, of course. The parameter is going to be the node. Base case is always going to be if not node. Go ahead and return null. So we'll do that like this. We know that we're either going to return null at this point if we delete the current node, or we're going to return the node if we don't delete it, right? So we could use a couple if statements for that, but I think a concise way and also a pretty readable way is to have a variable. So I'm going to initially say my result is going to be the node. So we're assuming we're not going to delete this node, and that's what we're going to end up returning. But if we do delete it, and how do you know if we delete it? Well, if a node.value is in to delete, then we can say the result, well, now is actually going to be null. And we're actually going to do a bit more than just that. If you recall, if we're deleting a node, we probably want to remove that node from the result. So we can do that like this, result set dot discard the node. Remember, when we delete a node, we want to set its left and right child. We want to add its left and right child to the result. So we can do that like this, result set dot add node dot left. Now suppose node dot left is null. We probably don't want to return null in the result. So I'm going to just have an if statement. So if node.left, then execute this. I could put it on the second line, but I feel like that's actually less readable just because we're getting pretty nested here. So I'm going to go ahead and leave it there, but obviously it's not a big deal. I'm going to copy that. I'm going to then just kind of update it. Same thing with the right side, right child. If it exists, go ahead and add it to the result set. And that's more or less it for the deletion case. Next is the recursive step. Remember, we're going to obviously run DFS on the left side and right side. So just a couple of recursive calls for that. But remember that the return value is relevant in this case. Let's try to fit everything on the screen. But the return value for these is relevant because we do have to do the pointer manipulation if we want to actually delete the node itself. So here I'm going to say node.left is going to be the result of that. Node.right is going to be the result of that. So this is the entire solution. Let's go ahead and run it to make sure that it works. Well, I guess it would be the solution if we didn't forget one very important step to actually call the recursive function. That's always what I end up forgetting. So let's just pass in the root for that and let's do this. And there we go. It works. It's pretty efficient. This is not my first time solving this problem, by the way. It looks like I actually did solve it 4 years ago, a little over 4 years ago, actually. And if we look at how I solved it last time, I think it's pretty similar, but I actually do think today's solution was better than this one because it looks like I actually had to call the recursive function twice in that case. Honestly, not sure exactly why I did that. Oh, actually, never mind. I'm misreading this. That's the recursive call in the recursive function. It looks like this solution probably is pretty much the same. It's just that I didn't nest this function inside the other one. Anyways, hope you have a good day. See you soon.
त्यानं काय केलं?
Okay, so okay. So firstly, what we want to do is convert the list that we want to delete into the hash set. After that, we will have a solution hash set. In that, uh, if we want to delete this, first of all we have to return this. Okay, so everything is recursive First of all, we will go to the depth of the tree. If a particular node is present in the hash set that says that, hey, we want to delete this nodes. So if, let's say, 2 is there, so what we want to do is we want to delete 2 from the solution first of all, right? And sorry, delete 2 from the tree. How we will do it? We will return null to this particular one. And how we will return null? We will assign the left value of its to be the return value of this. So if we want to delete this, we will return none. If we don't want to delete it, we will return the node itself. So that's the solution. So let's first of all dry run the solution. So let's say this is our hash set in which we want to store, what was 3 and 5. Okay, so 3 and 5. So for 3 and 5, and this is our solution. First of all, we will go to 1, then we go to 2. 2 is not in present, then we go to 4. 4 is not present. Okay. Okay. So first of all, we will go to the 4. We will check the both of these are null. So we will return null and return null. So we will assign the value of it to be null, like there is no change. After that, we will go to 2. Sorry, we will go to 5, and in this 5 is present in this list, and since 5 is present in the list, we will return null here. Here we will return null, so our solution becomes like this, like null. Here this part is cut off. This part will be cut off from the solution. And after that, uh, we will add the 5 to our, first of all we have to add root, of course. After that, we have to add 5 to the solution. After that, we will go to the 3. Now here 3 is okay, so 3 is present in this hash set. Since 3 is present in this hash set, uh, we go to the first left and add this left to the hash set. So here will be 5, here will be 6, and here will be 7. After adding this, we go to the here, and since we have want to delete it, we will return null, and we will get the null as the solution here. First of all, convert the root to the root is equal to set of root. After that, no, first of all I have to delete to delete to delete is equal to after that we will have a DFS which will take a node as an input. In that particular DFS, we have to tell first that current node is equal to node, and if current node is present in the to delete set, then we want to assign the current node to be none, and we also want to delete it from the solution. So solution dot discard what node. After doing that, we will check uh, if node dot left is present, then we want to add the it to the solution dot add node dot left, and similar with right. After doing this, so we will have the node dot left is equal to dfs of node dot left, and node dot right will be dfs of node dot right. And one more thing, if node is none, then return none. Everything is fine. You just have to call the dfs on root, and we have to return the list and the solution. Mm. Okay, so we are getting wrong answer. What the hell happened? We only have one. We wanted 1, 2, 4. Mm. Where did we go wrong?
Hey everyone, welcome back to
It's not known. The result current node discard node. Oh, the current node. Node dot left is good. Hmm. काय विषय झाला बघ बरं जरा.
well, I guess curse first time, and let's do that.
if check करूंगा तर ते बरोबरच आहे.
डॉट व्हॅल्यू
वरचा एक
डॉट
वरचा एक
व्हॅल्यू पाहिजे होता रे. ते काय नाही सोडे. इज नॉट इज नल ते काय.
झालं
हे आपल्याला सी प्लस मध्ये कसं करायचं बघायला पाहिजे जरा.
अरे मला ते पायथॉनचं काय ते ऑप्शनल काय विषय ते काय कळालं
हे ऑप्शनल वे म्हणजे इथं ट्री नोडचा
ऑप्शनल
अरे हे आहे का नाही, ही कोलनच्या पुढचं असतं का नाही ते म्हणजे डाटा टाईप असते रे. डाटा टाईप कोणता आहे ऑप्शनल म्हणजे
एवढं काय खास नाही.
ऑप्शनल म्हणजे दिला नाही तरी चालतंय. नल व्हॅल्यू पण असू शकते
हम्म,
थोडक्यात. नन व्हॅल्यू नन असणार किंवा ट्री नोड असणार. आणि ही
हो.
बाण आणि ही म्हणजे रिटर्न व्हॅल्यू असते.
हम्म.
I think this is the perfect time to learn about AI, the artificial intelligence, because the hype is over.
बरं काय करायचं आता?
मी नेटिव्हचं बघायला लागलोय ते काय सेटअप होते का. माझ्यात आत्ता काय ते काय आलंय अँड्रॉइड इम्युलेटर घेतलंय व्हर्च्युअल इम्युलेटर.
हम्म.
आता ह्याच्या पुढे ते नेटिव्हचं काय सेटअप होते बघायचं.
हम्म. हम्म.
एकदा नेटिव्ह सेटअप झाला की ते नेटिव्हचं करूया का आणि कुठलं करूया.
नेटिव्हच करायचं.
हम्म.
माझा एम्युलेटरच गायब झाला, दिसेना इथं.
इम्युलेटर
एम्युलेटर कुठं दिसेना रे.
माझे 2 GB नुसतं डाउनलोडच झालं आणि अजून बुटच व्हायला लागले. पिक्सल फोल्ड मला पिक्सल फोल्ड येते.